ahead and get started here. So, appreciate everybody attending the last session of the day. Hopefully today has been really great. I know I'm standing between you and dinner plans and everything, but very exciting topic. We're going to be talking about Kinesis and streaming analytics on AWS. So, what to expect from this session. We're first going to be talking about streaming analytics and really what streaming analytics means. When you talk to people about streaming, there's video streaming, which is something different, and then streaming analytics. And really what we're talking about here is a velocity of events going into your system. So that could be IoT sensors for GPS for buses in the city. It could be heart rate monitors for people out collecting from IoT devices. Lots and lots of things generating real-time data and needing to ingest that data and either store it into a durable store or run analytics on that data. Out of curiosity, how many folks in the room are running streaming analytics today? Okay, a handful of folks, so no, that sounds good. So we're going to really dive into Kinesis. We'll go through the three services that really Kinesis is made up of, but then we're going to dive very, very deep into Kinesis Firehose and why folks use Firehose, why we built Firehose based on all the user and customer feedback. So the three services that really make up the Kinesis service is, the first thing is Kinesis Streams. And the reason why folks use Kinesis Streams is when they really need the full flexibility to be able to process, analyze, and really run their algorithms on a streaming set of events. You're able to do things like use open source technologies, and we'll talk about some of those, such as Storm and Spark Streaming. But we also have some services that make it very, very easy for you to run your own client libraries on top of that. Kinesis Client Library is one of those. But it really gives the engineers and the developers the full flexibility to really do any type of processing on the consumer end of that stream. Based on that customer feedback that got released in the 2013 timeframe, based on that customer feedback, we actually released Kinesis Firehose. Kinesis Firehose is really set to address the use case where you have that streaming of events coming into your system, and you need to durably store that into a repository like S3, Redshift, or Elasticsearch. And we'll dive into a lot more of the details there. But that was a very, very common pattern. I have all this telemetry data. I need to store it and later on do some deep analysis on it using things like Spark R and EMR and those sorts of tools that you've been hearing about today. The last service, this service is currently in preview mode, but it's a very, very exciting service that makes up that portfolio of that Kinesis falls under, is Kinesis Analytics. The really powerful thing about Kinesis Analytics, where the first two really dealt with collecting and storing the streaming events, Kinesis Analytics is really a self-contained service to be able to process the streaming events. One of the really powerful aspects of Kinesis Analytics is it's SQL-based. So when you have business analysts and you have folks that know SQL, it's very, very easy to start analyzing your stream of events. And we'll talk about how some of that works. But the majority of the time is going to be focused on Kinesis Firehose. That is really a service that we released because it was a very, very common use case that we saw across our customers and based on that feedback. As I mentioned, the Kinesis Analytics is in preview. You can log in and you can request preview access. But kind of look for that in the future. So, a common use case that we see when it comes to streaming analytics is, the first is that they have the streaming need, or they have all this data getting generated. Could be one spot, or it could be geographically distributed across a region or a set of locations. But the first use case that we see most customers take, even in IoT and gaming and public sector, is really being able to collect, transform. That transformation might be a simple transformation or a complex transformation, and really load that data. And that's really one of the niche positions why folks use Kinesis Firehose, is it really does that very, very, very well. Once you're doing that, the next step is to really start running analytics on that data set. There's the deep analysis using things like EMR and Spark and those sorts of tools, but also being able to perform real-time metrics on that stream of events. After you do that, you're able to start getting a real-time view of that, and the next stage is really folks end up taking that real-time information and embedding it into their business dashboards. And this is where you really start making a lot of real-time business impact for your customers and for your mission. Being able to, in real time, and we'll talk about what real time means, but in real time, being able to collect information about telemetry information or users or whatever that streaming data is, and be able to really react and change your behavior based on that. And that's really, the third step that we see customers go through. So, we're still talking about the three broad services that make up Kinesis, the Kinesis Streams, Firehose, and Analytics, and they all really fall into these key characteristics. The first, like all the AWS services, is it's very easy as a customer to be able to provision and scale the streaming analytics within their environments. Of course, IAM protects all that, so the customer has the full flexibility to control who has that functionality or that access, and audit all that behavior in CloudTrail. But it really empowers the user to be able to do that on their own and really elastically grow that based on their demand. Not only that, but being able to do that at scale and making it highly available. And we'll talk about how Kinesis Streams and Kinesis Firehose really lets you focus on the streaming analytic rather than doing things like how am I going to manage the leader election algorithms, and how am I going to stand up a coordination service, for example, Zookeeper is a coordination service. All of that is handled as a service for you, and you're really able to focus on what matters of processing that streaming events and extracting that business value out. Real-time is a key for Kinesis Streams. So oftentimes when we're working with Kinesis Streams and our customers, we're talking about a 2-second type latency from the time that it gets published and processed. And of course, pay-as-you-go model. So it's very easy to start small, start with a single shard, and we'll talk about what that means, within a stream, and then be able to grow that really based on however much you grow and shrink your demand for. So within Kinesis Streams, the first part about Kinesis Streams is it's very, very easy to administer. Or the way you set up Kinesis Streams is you really just create a stream name, and that stream name is used by the producers and the consumers. As a customer, or through scripting and through different programmatic interfaces, at runtime, you could dynamically change the shards that define the stream. And the shards are actually the mechanism to grow and shrink the capacity that stream could handle. One shard could handle 1 meg input and 2 meg output, and we'll dive a little bit more deeper into that. Each shard is highly available. It's replicated across multiple availability zones, and we'll show some diagrams about that. But that's your capacity management mechanism. To be able to control the elasticity of how much traffic that stream could handle. Once it's on that stream, really, really great set of tools to be able to analyze that data. Spark streaming is a great one. Spark streaming uses a micro-batch methodology, running either on the Hadoop. A lot of folks end up running that on EMR. Or you could use Apache Storm. Apache Storm is a real-time processing engine made up of essentially a topology to process data as it's coming off of the stream. And then really the other option is for folks to be able to leverage the KCL. The KCL is the Kinesis Client Library, And what that does is it's another mechanism for you to focus on your processing logic rather than the logic to actually read the data off of the shards. So the KCL, it's an open source project on GitHub that you could download and look at the source and run yourself. But when you're running that, what happens is the KCL automatically handles iterating all the records across the different shards, even if the number of shards changes over time, because your capacity requirements might change. And all of that is abstracted away from you so you could focus on the processing and not how to read the records. But really with this, why this has really taken off is being able to have full flexibility to be able to use these different consumers and producers. You could use very, very low-level AWS SDKs to be able to produce and consume the data. Just like we have a KCL for consuming data, there's a KPL, a Kinesis producer library, to be able to easily produce data on top of the Kinesis stream. But you also have a lot of open source projects that have really nicely integrated with Kinesis Streams. A lot of folks that are using Log4j, Flume, and FluentD, for example, those are pretty well-established open source projects to be able to stream data from consumers, and Kinesis is able to become a destination for that. So you could use those at your application, and it could stream directly into the Kinesis stream. On the consumer side, again, you could use the APIs natively. You could use the client library. We also have a set of other libraries on GitHub. One's a connector library that allows you to very easily do ETL processes to be able to take data off of the stream and load it into other repositories, as well as some aggregators to be able to do very, very custom aggregations of data. And all that data, or all those libraries, are on GitHub open source for you to use. Of course, Elastic MapReduce, Apache Storm, and Apache Spark are used quite a bit. When a producer produces a message and puts it on the Kinesis stream, what happens under the covers is, of course, authentication and authorization happens first using that common denominator of IAM to make sure that that producer is allowed to produce that message. But once that happens, that message is actually replicated across 3 availability zones. And that's done for durability, for high availability. Just probably everyone in the room is familiar with an availability zone, but availability zone within the region is really a separate set of data centers that make up a single AZ that's isolated from the other AZs for fault tolerance reasons. So when that message gets published, it's within that larger region, for example, North Virginia, it's automatically replicated across those different 3 AZs. When that message gets published, what happens is that becomes a time-ordered series of events that are put on the shard. So as producers are reading the data off of the shard, within the shard, it's actually a time-ordered series of events. And what you could have is you could have a very large number of consumers consuming that message, those sets of messages, for different purposes. So one set of consumers could be populating a real-time dashboard, while another set of consumers might be doing a scan over 7 days worth of streaming data to be able to provide some other analytical results, once a day or something like that. So very, very decoupled from the producers and consumer sense, real-time in nature, 1 second, 2 second latencies, and really being able to have full flexibility of different sets of consumers to be able to process and analyze your streaming data. Apologize for looking back. This screen isn't on down here, so. So, Kinesis Streams, very, very powerful, but like we were talking about a couple minutes ago, very, very common use case was to have all of this event data getting published, and wanting to do things like storing all that data in S3, storing all that data into Redshift to be able to run Tableau, QuickSight, those sorts of tools on top of. So, what we did is, like many of our services, or really all of our services, we listened to our customers, and released a new service that is going to be coming on a couple slides. But related to that, we also released a few new features really this past year for Kinesis Streams. The first was to really be able to optimize the publishing of events on top of Kinesis. What we released was being able to do batch loading of records. So rather than doing one call per record, you could actually load, n number of records and publish those on top of the Kinesis Streams. Those could have different partition IDs, which fan out to different shards. Also increase things like the max size of the messages and other optimizations to really improve the producing side of the Kinesis stream. The other thing we did is really expand the number of, or the different types of languages that the KCL supported. Originally, it was done in one language, and now we also support Python, Node.js, and Ruby. And also released the KPL. Many folks like the KCL, and we got some feedback saying, I really wanted to ease the development, let me focus on generating the messages and help me produce some easier. So the KPL got released. And pretty recent, we also released server-side timestamps to be able to have that on the metadata of each event that gets published as well. So that becomes part of the metadata, so when you're reading the shard, you know what the shard ID is, you know what the sequence number ID is. You also get a timestamp variable. And then last but not least, really great enhancement is being able to extend how much data is really saved on your stream up to 7 days. And what this means is prior to this release, as data was getting read off of the stream, consumers were able to read the last 24 hours of data. Now you could actually expand that up to 7 days worth of data and be able to, backplay and reprocess all that data. The other thing that we recently released, this got released last re-event, was Kinesis Firehose. Kinesis Firehose is really focused on that use case of having that streaming events and being able to persist them and do back-end processing later on that data. Within the Kinesis Firehose, instead of doing things like setting up a shard for capacity, so with Kinesis Streams, what you did is, since you had the total flexibility of producers and consumers, you defined the number of shards, and that drove how much capacity one stream could handle. With Kinesis Firehose, it's completely automated. You're still using the same sort of producers, but when it comes to managing the Kinesis Firehose, all you do is you really specify that destination. I want to write this to S3 or Redshift or Elasticsearch, and the rest is handled for you. You could produce as much data as you want on that Kinesis Firehose, or you could produce as little, and it will automatically scale and shrink based on how much it needs to based on that load. So it's really completely managed at a higher level above the shards. And you don't have to worry about anything when it comes to getting the data from the consumer's point of view. There's no consumers with Kinesis Firehose because the service is really configured based on your settings. So you configure the consumer. For example, and we'll step through some of the slides, but for example, you could configure it to write to the S3 bucket, and it will automatically have the code that knows how to do that. You configure it to write to Redshift, and it knows how to do that. The other thing that it allows you to do is, and really one of the key benefits here is Kinesis Firehose batches all the data together. S3 likes larger files, be able to do things like run MapReduce on it, to run Spark on it, the way the partitions work, the splits work when it's reading data. Larger files are better for streaming data when you're doing that back-end deeper analysis. So what it does is it batches the data for you based on your heuristic. So you say, I want the file to be this large, and it will follow that definition and store the data for you. You could also define a time window. So in addition to the size criteria, you could specify as little as 60 seconds, and it'll take all the events that happen within that time window, even if it didn't reach that size limitation, and write that out. So those are the two variables that really define the amount that gets batched. The other thing that happens is you're able to optionally do things like encrypt your data with KMS keys, so the key management service. So when it's writing the data out to S3, you could specify what keys you want to perform if you want encryption turned on. You could also specify things like compression and what compression algorithm you want to use to compress the data when writing it out. And one of the reasons why this has really taken off is, it is a common use case, but when it comes to managing the scale and elasticity, it's very, very hands-off. All you need to do is define a delivery mechanism and start producing to it, and the service itself will handle the writing the data out to that delivery channel, that delivery stream. So this is depicting, the updated version of what Kinesis Firehose looks like. Kinesis Streams is still used quite a bit, but when you do need to do that batching and offline or batch processing of the data, the producers that you use are the same exact sort of producers. So you could use Kinesis producer library, you use the SDKs, you could use the FluentD. All the other producers that you saw on the previous slide are the same sort of producers you could use with Kinesis Firehose. Because from that point of view, all the producers are doing is producing data. It's producing streaming data. It's not aware of how you want to process the data. On the consumer side, there are no consumers from the customer's perspective, and what I mean by that is all you do is you configure that definition, S3, Redshift, or Elasticsearch, and you can do combinations of these. So, for example, when it writes out to Redshift, it's actually writing out to S3 first when you set that up. The very, very common use case is using IoT. Within IoT, there's a feature called IoT rules, and what that allows you to do is each message that comes in from all the sensors that you may have, all the controls modules that you may have within your IoT, you could define an IoT rule. And one of the actions that IoT rule could take is to actually publish onto a Kinesis Stream or a Kinesis Firehose. So very, very easy to use our IoT service to have sensors out in the wild, essentially, producing messages, and then have that all stored within your S3 buckets and BI tools. So, why this is important, that first use case that folks usually get started when it comes to streaming data is collecting all that data and being able to process it, using these, well-established tools. And Firehose makes that very, very easy. So you could stand that up and get started, very quickly with Kinesis Firehose. So when you're defining Kinesis Firehose, what happens is instead of a stream, you define a delivery stream. So what you don't have to do is, like we were talking about, is define the shards. You don't have to specify a partition key. So the way the Kinesis Streams works is when the producer is generating the data, it generates a partition ID, and that partition ID is used to fan the traffic across the various shards on that stream. With Kinesis Firehose, you don't have to specify any of that. That fan out all happens under the covers for you. The records are the same sort of format and syntax as Kinesis Streams. They're really any blob up to a megabyte could be handled on the Kinesis Stream or the Kinesis Firehose. And what happens is that data ends up being used in order to be put in as a row within S3. So if it's, for example, if you're generating temperature sensors, each message might be, what the sensor was and what the temperature is, and that becomes various rows that all get appended together in one batch load into S3 or Redshift. And the data producer, all this data producer really needs to do is know how to write out using one of those open source tools or using one of our API calls, which is very, very easy to get started. Lots of great examples on GitHub. So next few slides, what we're going to do is we're going to step through how some of this is set up within Kinesis Firehose to really show how simple it is to stand up this delivery stream and be able to start having this very, very elastic, highly available delivery stream to be able to save all your streaming data. So when you get to the landing page, right now what you'll see is Kinesis Streams and Firehose because Kinesis Analytics is in preview mode. But when you go in there and you select Kinesis Firehose, what happens is you're able to configure the destination. So you give it a destination name, such as or a destination type. In this example, we're showing S3. Next examples will show Redshift and Elasticache. But you're able to do things like give it the S3 bucket. And the other important thing that you're able to specify is a prefix. That way, if you want all the files that get bashed and saved in S3 to have a prefix, which simulates a directory structure within S3, you could set that up in order for your different data to be able to be stored in one bucket, but all be grouped together based on different delivery streams. The next slide goes into some of that optional configuration that we were talking about. The middle section is actually the compression algorithm, the encryption algorithm. At the very bottom, you'll notice the IAM role. So IAM is used both by our services to be allowed to talk to other services, as well as by users and EC2 instances and those sorts of things. So that IAM role is really what allows the Firehose service to do things like write to your S3 bucket, and you have control within that IAM role to really be very selective of what bucket it could write to and follow that principle of least privilege there. And then up at the top, you have the buffer size and the buffer interval, and those are really the two mandatory fields besides the IAM role here that define how big those chunks of data are that gets written out to S3. In this example, we're showing the Redshift configuration. So some of the very, very similar fields, but instead of doing S3 bucket and key spaces, it's now allowing you to find the Redshift cluster that it should write to. One of the things you'll notice is the middle section still has a S3 definition. And the reason why we do this is, it's a general best practice to really save your data out to S3 first. And what's happening under the covers is it gets saved to S3, and it's actually performing a copy statement to distribute the loading across all the compute nodes in Redshift to be able to load all that data into Redshift very, very parallel rather than trying to go single thread to the leader node or do something like that. So, and then the Elasticsearch service, this is a relatively new addition to Firehose. But here what you're able to do is define a Amazon Elasticsearch endpoint and be able to define the domain that you want to write to, the index, I have a pointer here, the index rotation, things like retry. If something doesn't work, you're able to define that retry logic, as well as what that S3 backup mode is. Do you want to only load the failed documents in S3 if for some reason something happens with the Elasticsearch cluster is serving a lot of queries, maybe it's elastically growing on its own, and you're able to specify how to handle different criteria down there. The other way to really publish messages on top of a Kinesis Stream or a Kinesis Firehose is using the Amazon Kinesis Agent. And the Kinesis Agent is, like many agents that you'd find in various situations, is a piece of software that gets loaded on one of the application OSs that you want to generate events from. And what it does is it really monitors the traffic on that, so you could configure it to listen to things like log files and generate messages for all the events that happen in that log file. You could listen to various sources, and what it will do is it'll run on that instance and publish messages to Kinesis Streams or Kinesis Firehose for you. It will do things like handle, a lot of logging technologies do file rotation, renaming of the files. The agent is smart enough to be able to keep trailing the same most recent file, even if the other file gets renamed and a new file handle gets opened up. It has some pre-processing capability. So, if you're loading something like a Redshift database and you want to pre-process that formatting to make that copy into Redshift much simpler, you could do that within the agent to really kind of stage and prep that format if you'd like. And it has all the retry and built-in logic to make sure that that message gets published out to the Kinesis Stream or the Kinesis Firehose. And how do you know that's working? Like many of our services, the KCL does this, the KPL does this. KCL being the Kinesis Client Library and the Producer Library or the Consumer Library. It publishes messages or metrics out to CloudWatch. So these metrics give you things like how well is the agent performing across your various instances. That way you could have that situational awareness in that single dashboard. And as we were talking about, it's also compatible with Streams. So this is something you could use with Firehose. One example is, if you have a whole bunch of transient instances that might, EC2 instances that are spun up and later terminated, but you want to save all the application log data off of that, you do things like you use this to go to Kinesis Streams. It could get written out to, Elasticsearch if you want to, capture that data and have search. There's some other patterns you could use. You could go to CloudWatch Logs, and CloudWatch Logs has Elasticsearch capability as well. So a few options when it comes to that sort of use case. And with Kinesis Firehose, very, very inexpensive to use for everything that you're getting. 3.5 cents per gig ingested. So Kinesis Streams, the way the streaming service works is it's really priced per shard. So this is with Kinesis Streams, where you have the full flexibility of producers, consumers, you grow and shrink the capacity based on the shard. That's how it's priced. Since Kinesis Firehose is completely managed for you, it's no admin to you. All you're doing is configuring that delivery stream and publishing messages to it. It's based on how much data you publish to that stream. And it's 3.5 cents per gig per month for the U.S. regions. Dublin, I think, is 3/10 of a cent more. It's like 0.38 for Dublin. So, what use cases would you want to start using Kinesis Streams, and what use cases would you want to start using Kinesis Firehose? So, if you really need to do very, very custom processing for incoming events, and that custom processing needs to be real time. You need to be able to have 1 second sub-lub 1 second processing of those events to be able to drive your metrics, drive your analytics. Then you want to use Kinesis Streams, because you could write those consumers and things like Storm, Lambda, use the KCL. Spark streaming, and you're able to implement that consumer logic very, very easily. if you really have all this streaming data, all this data is getting generated out in your enterprise or out, out in the world, and you want to be able to collect that data and then do processing of that data, every hour, every few minutes. You don't really have that real-time nature, but you have very, very high-velocity data that you need to collect. Kinesis Firehose is a great option because what it will give you is that endpoint to produce all that messages and save that into a durable location for you. And you don't really have to pick either or of these. Many, many times folks want to do both of these. And it's a perfectly acceptable architecture to have both of these used together in order to have real-time processing, but then be able to do back-end heuristical analysis later on your data. Next, what we're going to do is we're going to really dive a little bit into Kinesis Analytics. It's a very, very exciting new service to be able to really start processing or make it easier for folks to process real-time data. So really achieve that sub-second processing of data when you need it. So again, this is currently in preview, but what it allows you to do is really define a SQL definition of your analytic. So for example, if you have a whole bunch of atmospheric information, temperature, and different sensors out in the world, and what you want to do is you want to do things like take the average temperature, max temperature, run different analytics on that streaming data. It's very, very easy to form that in a traditional SQL syntax, doing different aggregation functions. What Kinesis Analytics does is it allows you to have that same notation and also qualify it with what time interval to do that aggregation on, and really define your analytics very, very in a simple syntax, but listen to, instead of running that on a database or another technology, run it on the actual Kinesis stream. It's also able to listen on your Kinesis Firehose. So if you do want to save that data to S3 or you do want to save it out to Redshift, you could also use Kinesis Analytics to be able to run some of that real-time computation, that real-time statistics on that data, and be able to do things like power dashboards and other use cases. And of course, it's built for scale. It will automatically grow based on how many shards you define or how much traffic is on that Kinesis Firehose. So you don't have to go in and really spec out how much compute your analytic would need to be able to process the data. You write your SQL syntax, and that's how you define that algorithm. These are some of the customers that are some of the public use cases that we talk about sometimes when it comes to Kinesis. What we're going to do is we're going to dive into a few of the architectures and step through some of those. And you can't see the lines on this screen for some reason. I apologize for that. But this is a ad tech company that is really in the market of serving bids and serving ads out to folks that want marketing space. And what you can see is, they're leveraging open source technologies to be able to produce messages. They're leveraging things like, they're leveraging Kinesis as their streaming service. That way they could focus on the producers and the consumers. And they have various consumers. One is an archiver to be able to load things into Redshift. The other is a event playback using the EMR cluster, and then a set of KCL applications. There's a great reInvent talk where they actually present some of this as well. I love sushi, so I like to talk about this use case. It's a very, very innovative use case. There's a sushi chain that they really want to improve business operations, and the way this restaurant works is there's actually a conveyor belt that has various sushi on it, and as patrons actually pick up the dish, that's how they're charged. So, everyone sees the dishes going around the conveyor belt. If somebody wants a dish, they pick it off and they eat it, and later on they get the bill. But what they want to do is they really want to optimize, what type of, sushi should I make in order to really optimize the flow, not have waste, that sort of thing. So each sushi plate actually has a sensor on the bottom to be able to recognize, how long it's on the conveyor belt, and how long did it sit there before it got picked off and eaten by a customer. To do this, they're leveraging a few services together. The first is using Kinesis to be able to collect all of that data from the various data feeds. Excuse me. And then they're using things. They're loading it using a Kinesis app into Redshift. Redshift is a very, very wonderful data warehouse to be able to run BI and a lot of complex queries on top of. And in front of that, they're leveraging Tableau in order to really visualize the data, build various reports, and really optimize their processing flow or their supply chain. The last one I wanted to talk about is Hearst. Hearst is another one of our great customers, and the reason why I want to highlight them is, they're actually leveraging Spark to do ETL on top of EMR. So again, they're leveraging Kinesis Streams in this case, running Spark streaming on top of EMR. That way they could focus on the streaming application and not necessarily how to stand the whole Hadoop ecosystem, how to stand up the various daemons, that sort of thing. And then leveraging Redshift, S3 with Firehose, and Elastic for some of their API. End-to-end, all the way from the beginning of this flow into their final repository, it takes about 135 seconds to really populate that back-end repository for them. And that, the reason why they set up that, that's what they needed to do for their use case, but considering what it's doing across that entire flow, being able to have that in the backend API that quickly is very powerful. And you can see some of the sizing when it comes to the throughput as well there, or you could partially see it. You can see it a lot better on the normal screen. 100 gigs per day, 5 gigs, 1 gig, and then 1 gig. So. I wanted to thank everybody for the time. I know dinner's waiting here, so I'll stay up at the front here if there's any questions, and definitely appreciate everyone's time.